Another example on law of cosines and why we need the law of cosines, that we can't exist in a world just with the Pythagorean theorem and law of sines, is when the information we're given involves the three sides of a triangle. So all we have are the three sides. We don't have any angles. So we are not able to use the law of sines because we can't make a partner ratio. We don't have any angles. And the approach we're going to take is we're going to use the law of cosines first to find an angle. And then we're going to use the law of sines to find a second angle. And then last here, we're going to subtract the two angles we know from 180 degrees to find the third angle. So in this first step here, where we use the law of the law of cosines, the first thing we're going to go is we're going to look for that longest angle. So if we have any obtuse angles, any angles that are greater than 90 degrees, we're going to find them right away in this first step, so that when we come to our law of sines, we don't have to worry about is it from Q1 or Q2. It's not going to be able to come from Q2. So we can just find the angle using the law of sines and be finished with our answer, not have to look any further. And then third step would be the subtraction of the two angles from 180 degrees. In the example we're given for this triangle ABC, we have the three sides here, side A, side B, and side C. We want to find the biggest angle first. So to find the biggest angle, we need the longest side, which is B. So we're going to have B on this side of our equation, on the left side, and then cosine B over here. So I'm going to write the version of the formula just so you can follow it. We have B squared, and now this is going to be equal to the other two sides squared minus 2 times the length of those two sides, AB. This is C here. That was a big brain blip. So we have C squared, and then this is the cosine of B. So side B, and then the two other sides, A and C, A and C. And then cosine of angle B. So here's our partners, if you will, side B, cosine B. So now let's put our information in. B is 10, so we have 10 squared. A is 8, 8 squared. Side C is 5, C squared minus 2. A is 8, C is 5. And now cosine of B just has to stay like that because we don't know what angle B is. Again, I'm going to show the calculations in at least a couple of steps here so you can follow along. We have 8 squared is 64, 5 squared is 25, and then minus here, 2 times 8 times 5, we have negative 80 cosine B. So to solve for the cosine B, we can subtract 64 and 25. And so I'm going to write it like this. The cosine of B, if we subtract 64 and 25 from 100, we get 11 over here. And then dividing both sides by negative 80. So we have the cosine of B is equal to 11 over negative 80, or you could also consider this as negative 11 over 80. It doesn't really matter. We find the inverse cosine of this to find our angle B. And so what we're going to get here is that B is approximately equal to 98 degrees. Now let's look at this. This is negative. This is saying the cosine of this angle B is negative. So we know it has to come from Q2 because cosine is positive in Q1 and negative in Q2. And again, the angles from our triangle can only come from Q1 and Q2. So this says here that this B is going to be in Q2. So when you do this here, let me write this here. When you do cosine, so inverse cos in your calculator of negative 11 over the 80, this is what you'd input in your calculator to get this answer here. And it should make sense that it is going to be from Q2, so it's going to be bigger than 90 degrees here. Now we have, well, we started out with all three sides. We have one angle. We have yet to find two angles. So in order to do that, we switch up now to the law of sines. And being that we have B, angle B and side B, my law of sines, it's going to be side B over the sine of B. And side B is 10, so we have 10 over the sine of 98 degrees. There's my first ratio. And here we don't have to worry about the longer side or shorter side like in the other example. We can choose any of the angles to proceed with. So I'm going to go ahead with finding C. So this is going to be 5C over the sine of C, which we don't know we're going to solve for. So here's my law of sines to find now angle C. Cross multiplication, we have 10 times sine C is 5 sine 98 degrees. Sine C is going to be 5 times sine of 98 degrees all over 10. And solving, if we can do this two ways. We can either do inverse sine directly here to find the angle, or we can do this calculation out of this fraction, and we get that the sine of C is approximately equal to 0.4951. Now when we do inverse sine, we get that C, angle C, is approximately equal to 30 degrees. So in this problem, just, oh, by the way, be careful with your inverse trig functions. Here we're using the law of cosine, so it's going to be inverse cos. Here, because we're using the law of sines, it's going to be the inverse sine function. And now last but not least, to finish this up, we need to find our angle A. So angle A plus angle B, which is 98 degrees, plus angle C, which is 30 degrees, is going to be equal to 180. And now when we subtract the 98 and the 30 from the 180, we get that angle A is 52 degrees. Obviously, you could set this equation up differently to solve. I'm doing it like this. If you wanted to say directly that A is equal to 180 minus 98 minus 30, that's same information, just stated differently algebraically. You get the same answer.